Hello my dear friends, students, and viewers. This is Sir Palmath and welcome to my video channel. In this video, this is the part 2 of our video lesson which we are talking about the division of radical expressions. Specifically, we are discussing about rationalizing the denominator. So my dear viewers, let us begin with our learning objectives for this topic. So today, our main objective is we will be going to use the quotient rule in order to us to simplify radical expressions, and we will be going to simplify radical expression by the use of rationalizing the denominators. So my dear viewers, so that is our learning objectives for this topic. So are you ready to study and learn about the division of radical expressions by the use of rationalizing the denominators? So let's start. So today, let us recall about the quotient of the roots, or it's what we call the quotient rule. So that's we have already discussed on the previous video. So quotient of the roots, it states that if any real number a and b are real numbers, and a is greater than 0 and b is also greater than or equal to 0, then so our formula for the quotient of the rules is denoted by the nth root of a all over the nth root of b is equal to the nth root of all over a over b. So in general, the quotient of the principal nth root of two real numbers is the nth root of the quotient of the numbers. So let us proceed for our next session of this topic. So in connection of this, our previous topic, let's consider the given example. So how will you simplify the square root of 5 all over the square root of 70? So my dear viewers, so we all know on how will we going to simplify this radical expression. So we have already learned on the previous video. So how will you going to simplify this? So let us recall that we are going to apply this radical expression by the quotient rule. So we all know that the quotient of two roots, square root of 5 and square root of 17, so which is expressed as the overall quotient, which is the square root of 5 all over 17. And we will be going to simplify 5 over 17. So we all know that 5 is a prime number and 17 is also a prime number. So the quotient of two prime numbers, 5 and 17. So 5, which is not divisible by 17, so cannot be. So by the use of calculator, so we computed that the square root of 5 over 17, which is equivalent to the square root of 0.29411 and so on. So by the use of calculator. So non-terminating decimal inside the radicand, which is resulted to irrational number. So meaning to say that if you will be going to simplify this square root of the given non-terminating decimal, the result is irrational numbers. So and the result of these calculations, which is endless. So meaning to say, non-terminating decimal, whose kind of decimal, whose all of digits are endless. So in this case, in the given example, you need, in order to use another way of simplifying the radical expression, which is expressed as the quotient, by means of rationalizing the denominator. So this is the another way in order to us to find the quotient of the two radical expressions. So today we'll be going to discuss on how we'll be going to rationalize the denominator when you're going to get the quotient of two radical expressions. So in this case, a radical expression is not in the simplest form if the denominator which contains a radical. So you need to rationalize the denominator, that is writing in the expression in that way, that there is no radical in the denominator. Supposed to be in the given radical expression So there is no radical sign on the denominator in the given fraction. So for example, when you going to convert into original in the quotient form, so the quotient of the two roots, so the square root of 5 all over 17, which is going back to square root of 5 over square root of 17, where square root of 17 is the denominator. Supposed to be that there it could the sign of the radicand must be eliminated. So, and we all know that 5 over 17 could not be easier to simplify the square root of the non-terminating decimal, so which is difficult to simplify that. So there is another way to rationalize the denominator. So this can be done by multiplying the numerator and the denominator by the number. That will give a rational denominator. So in this case, you will be apply the multiplication law of fractions. So consider that the equivalent or the calculated equivalence of 5 over 17, which is equal to the square root of 0.29411, so which is difficult to simplify. So instead of expressing this radical expression into decimal, so we'll be going to rationalize the given denominator. So let's go back to square root of 5 over 17, so which is expressed to the quotient of roots. So it becomes square root of 5 over square root of 17. Okay? So the next thing to do is focus on the denominator. So square root of 17, which makes a perfect square, and it could be eliminating the radical sign. So then which is multiplied by 1. So that is equivalent by multiplying the fraction by 1 so that the value of the fraction is unchanged. Meaning to say that the numerator and the denominator are the same or must be equal. So given that the denominator, which is square root of 17, so hence that the equivalence of 1 must be equal to the numerator and the denominator, which is square root of 17. So square root of 17 divided by square root of 17, which is also equivalent to 1. Okay? So the fraction, the numerator and denominator is unchanged. So which is still the same. Okay, the next step to do is to multiply by the same denominator. We have the numerator and denominator, which is square root of 17 is equal to square root of 17. And that is equivalent to 1. Okay, the next step to do is to apply the laws of multiplication of fractions. So we have the numerator multiplied by the numerator, same way the denominator by the denominator. So square root of 5 multiplied by square root of 17, which is also express a product rule of radicands. And of course, square root of 17 times square root of 17, so which is expressed into exponents, so which is square root of 17 squared. And after that, we will be going to eliminate the exponents with the same order, so which has an exponent of 2 and it's the index order, which is square. So square root and a perfect square, so we can eliminate the exponent of 2 and it's the radical sign. And that is, we have remaining denominator, which is 17. So we get the product using the product rule of radicals, 5 times 17, which is square root of 85. So that is the final answer, which is square root of 85 over 17. So my dear learners, so now you know on how we'll be going to rationalize the denominator. So instead of using by simplifying the quotient of two numbers inside the radicand with their non-terminating decimal, so we use rationalizing the denominator. So my dear learners, so this is the part 2 of the division of radical expressions. So in order to learn something more about rationalizing the denominator, let us discuss some of their illustrative examples. So let us begin with illustrative example number 1. So how will you simplify the square root of 75 all over the square root of 2? So to simplify this kind of radical expression, here is our solution. So to simplify that kind of radical expression, so you will be going to simplify this. So first things first, what we're going to do is to focus on the given denominator. So the denominator, which is the square root of 2. Okay, the next thing to do is to rationalize the denominator. So we all know that square root of 2 is the denominator. So you will be going to rationalize by multiplying by 1, which is the numerator and denominator are unchanged. So never change with the numerator and denominator, which is the square root of 2 all over square root of 2. Okay, the next thing to do is to apply the product of roots. So 75 or square root of 75 multiplied by square root of 2, which is square root of 150. And for the denominator, square root of 2 times square root of 2, which is square root of 4. The next thing to do is to factor out perfect squares. So we all know that the factorization form of 150 by pair of numbers, which is 25 times 6. So at least we have only one perfect square factor should be eliminated outside the radicand. And after that, you will be going to extract the roots. So we all know the square root of 25, which is equal to 5, and remains 6 inside the radicand. And copy the denominator, which is 2. So 5 times the square root of 6 all over 2, and that is our final answer. So to firm up with some of their illustrative examples, so let's move on to our next. Illustrative example number 2. So how will you simplify the cube root of square root of 2 all over the cube root of 3? So to simplify this kind of radical expression, here is the solution. So our objective is to simplify this kind of radical expression. So by the first step to do is to determine the denominator. So we all know that the denominator, which is square root of 3. Okay? So square root of 3, we all know that the nth order of this radicand is cube root. So in order to us to rationalize the denominator, we must find the perfect cube number which is used for base 3. So a perfect cube number belonging to the perfect, which is the base 3, which is 27. And of course, we find a pair of numbers which has a factor of another number in the given denominator. So we all know that 27 is divisible by 3. So the other factor, which is 9. So we get that by rationalizing the denominator. So 3 times 9, which is 27. So cube root of 27 is also a perfect cube. So we have the cube root of 3 times, of course, cube root of 9 all over cube root of 9, which is equivalent to 1. So by means of rationalizing the denominator. Okay, the next thing to do is to apply the product of roots. So the cube root of 2 times cube root of 9, which is the cube root of 18. And for denominator, cube root of 3 times cube root of 9, which is the cube root of 27. Okay? So simplify the denominator. So extract cube roots instead of square. So cube root of 27, which is equal to 3. So the final answer is the cube root of 18 all over 3. And that is the final answer. So let's move on to our next illustrative example. How will you simplify the cube root of 11 all over the cube root of 5n? So to solve this kind of radical expression to simplify, here is the solution. So same thing to do, you will be going to rationalize the denominator. So you all know that the denominator, which is the cube root of 5n. Okay? So the cube root of 5n, which is also on the denominator. So we find the possible perfect cube number which is related to the numerical coefficient, and it's the literal coefficient. So we all know that the base 5 is one of their number. So the perfect cube possible, which is 5, which is 125. Okay? So the number should be multiplied to make a perfect cube, which is 25, and of course for m, which is m squared. So we multiplied by the cube root of 25m squared over the cube root of 25m squared, which is equivalent to 1, by the use of rationalizing the denominator. Okay, the next step to do is to apply the multiplication rule for radicals. So the cube root of 11 times the cube root of 25. So we all know that cube root of 275, and then copy m squared. Okay, next is on the denominator. So we multiplied 5 times 25, so we get 125. And of course, m times m squared, so we have m cubed. Okay, the next thing to do is to extract cube groups if possible. So, since that 275 is not a perfect cube, also with m squared, so it cannot be, so just copy on the numerator. Next is, we'll be going to simplify the denominator since 125 is a perfect cube and m cube is also a perfect cube, so we get the perfect cube root of this denominator. So 125, which is 5, and m cubed, so 3 divided by 3, which is 1, or m. So the final answer is cube root of 275 m squared all over 5s, and that is our final answer. So my dear learners, so here is another case. So how about if the denominator that will containing two radical terms? So if we will be going to rationalize the denominator which are going to containing two radical terms. So in just case, we will use by rationalizing the denominator by its the conjugates. So are you familiar with the word conjugates? So in terminology in mathematics, we discussed the terminology that we are going to recall about conjugates. A conjugate is formed by changing the sign between the two terms of a given binomial. So let us say example. So the conjugate of x plus y is x minus y. Okay. So we notice that in every middle terms or of the sign between these two terms, we get the opposite. Instead of positive, we have that the conjugate, we get negative. Okay, same way the conjugate of 3 minus AB is 3 plus AB. So instead of negative, we get the conjugate, we get positive sign. Okay? So to come up with this, or we apply the conjugates to rationalizing the denominator. So hereby some of the illustrative examples on how will you rationalize the given radical expression of this denominator of two terms using the conjugate. So let's start with on the first example, which is illustrative example number 4, to rationalize 15 all over the square root of 3 plus the square root of 2. So to rationalize the given radical expression, so here is the solution. So in order to rationalize this kind of radical expression, so let us focus on the denominator, which is square root of 3 plus square root of 2. And we find their conjugates. So we all know that the conjugate is we're getting the opposite of the between these two terms. So the sign. So the conjugate of square root of 3 plus square root of 2 is square root of 3 minus square root of 2. Okay, so we interchanging the sign. If it's positive, it becomes negative. So that is very easy. Okay, and then we apply rationalization, the denominators, which by means of conjugates. So we all know that 15 all over square root of 3 plus square root of 2, which is multiplied by its the conjugates. And we all know that the numerator and the denominator are unchanged since which is equivalent to 1. So which is multiplied by square root of 3 minus square root of 2 all over square root of 3 minus square root of 2, and that is their conjugates of the denominator. Okay, the next step to do is to simplify the denominator by difference of two squares. So we are familiarizing that we get the perfect square of the first terms, and we get the perfect square of the last terms, and we get the product of these signs. So we all know that the square root of 3 times square root of 3, which is square root of 9 by the product rule, and we get the square root of 9, which is 3. Also, square root of 2 times square root of 2, which is 4. Square root of 4, it becomes 2. And we have positive times negative, that is negative. So that is the shortcut. So what we're going to do is to get the radical sign which has expressed in subtraction or the difference. So we copy the difference and then we eliminate the radical sign. So that is 3 minus 2. Okay? The next step to do is we'll be going to distribute 15 using the distributive multiplication. So 15 times square root of 3, it becomes 15 times square root of 3. And 15 times square root of 2, which is 15 square root of 2. And 3 minus 2, it becomes 1. So That is very easy. So division by 1, so the answer is still the same on the numerator. So that is 15 square root of 3 minus 15 square root of 2. And that is our final answer. So another example, let's move on to the next. Illustrative example number 5. So you will be going to find the quotient square root of 5 minus 3 all over square root of 7 minus square root of 2. So to solve this quotient using rationalizing the denominator, here is the solution to the given problem. So in order to us to rationalize the given quotient, so square root of 5 minus 3 all over square root of 7 minus 2. So we found out that when the given denominator square root of 7 and square root of 2, the conjugate is square root of 7 plus 2. Okay? So that is very easy to understand the concepts of conjugates. So in the same manner, you will be going to rationalizing the denominator by its conjugate. So we all know that the denominator is square root of 7 minus square root of 2. So we multiplied both the numerator and denominator by its conjugate. So we change the sign. So square root of 7 plus square root of 2 over square root of 7 plus square root of 2. Okay, next we could be apply by simplifying the denominator by the difference of two squares. So one of the special products. So simply that the answer always between the sign which is negative, and we could eliminate this radical signs. So that is 7 minus 2. So that is very easy. And on the numerator, we could be apply the product rule. The next step to do is you will be going to simplify the numerator using the FOIL method. So when we say FOIL method, so the acronym for FOIL means the first, the outer, the inner, and the last. Okay? So let us start with the first term. So square root of 5 and square root of 7. So by the product rule, so which is square root of 35. So next is letter O, which is the outer. So the outer, which is square root of 5, the first term of the first factor, and of course the next term or the second or the last term of the second factor, which is square root of 2. So we have square root of 5 times square root of 2, so the product, which is square root of 10. Okay, the next is the inner terms, which is negative 3 and square root of 7. So negative 3 times square root of 7, so we get the product, which is negative 3 minus 7. And for the last terms, which is negative 3 times square root of 2. So negative 3 times square root of 2, so we have copy this with negative 3 square root of 2. And 7 minus 2, which is 5. So that is the denominator, which is 5. So the final answer is square root of 35 minus 3 square root of 7 plus square root of 10 minus 3 square root of 2 all over 5. So that is the final answer. So these are the terms of the numerator are different. So let's move on to our last illustrative example. So how will you find the quotient of the given radical expression square root of 2 plus 2 square root of 6 all over square root of 6 plus square root of 2? So to simplify this kind of radical expression to find this quotient, here is the solution. So the solution is very long. So we all know that we self-explanatory. So we get the conjugate of the given denominator. So square root of 6 plus square root of 2. So we get the conjugate, which is square root of 6 minus square root of 2. So by multiplying both the numerator and denominator, which is equivalent to 1. Okay, the next step to do is to apply the product rule. So we all know that square root of 2 plus 2 square root of 6 times square root of 6 minus square root of 2 is like this. And for the denominator, the product of denominator, so we can be applied using special products by difference of two squares. So 6 square root of 6 plus square root of 2 times square root of 6 minus square root of 2, which is 6 minus 2. Okay, the next step to do is to using the product of two binomials, so which is square root of 12 minus 2 plus 12 minus 2 square root of 12 all over 6 minus 2. Okay, we are using the FOIL method. So first terms are square root of 2 times square root of 6, which is square root of 12. Okay, the next is square root of 2 times negative square root of 2, which is negative square root of 4 or positive 2. So we get the square root of 4. So negative. Next is 2 square root of 6 times square root of 6. So which is 2 square root of 36 or which is 6 times 2, we get 12. Okay. Next is minus. So 2 square root of 6 times square root of 2. So by the product rule, which is 2 square root of 12. Okay. Next is the red ones. We're going to simplify the red numbers, negative 2 plus 12. So we get the sum, which is 10. So minus, we simplify also square root of 12 minus 2 square root of 12. So combining like terms, which is negative square root of 12. So which is greater is negative value. And after that, we will be going to extract the root, since we will be going to factor out 12 inside the radicand. So the pair of numbers are 4 and 3. At least 4 is at least one perfect square number. And that is, we eliminate the perfect square number inside the radical side. So the square root of 4, which is 2. So that is 2 square root of remaining factor is 3. And then 10 minus 2 square root of 3 over 4. So we'll be going to reduce fraction to its lowest term. So we all know that the GCF of 10 and 4 is 2. Also 2 and 4 is also 2. So it could be divide numerator by the GCF simultaneously. So 10 divided by 2 is 5. So 2 divided by 2 is also 1, or we cannot omit 1 as the coefficient, which is square root of 3. All over 4 divided by 2, which is 2. So the final answer is 5 minus square root of 3 all over 2. So, and that is the final answer. So my dear friends, students and viewers, so now you know how you will be going to rationalize the denominator using the quotient of two radical expressions. So that's the end of our video. So thank you very much for watching. So this is Sir Palmath TV. So please like, share, subscribe, and hit the notification bell at YouTube channel. So see you on next video. Thank you very much, and God bless us all.